Hey guys, today we're going to practice 2 or 3 leak code questions. So I just picked some from the Medium top 100 interview questions. First one's going to be group anagrams, and just like always, we're going to be doing each question in a time limit of 17 minutes and 30 seconds. So let's get started. Alright, so for this group anagrams, given an array of strings, group anagrams together. So what is the anagram? Anagram is basically you use the same amount of letters, they're just rearranged. So with this, what I'm thinking is you could just loop through every single element in the input array, and then you could have subarrays within that loop, and then within that loop you can call a helper function to either sort the string and make sure that they match, or you could do a helper function where it does like a counter to increment and decrement certain letters and then make sure that those match. And if there's like a mismatch, then you return false, and then it doesn't get appended to the subarray. So with that, and then we would need a way to make sure that each subsequent element doesn't recreate these subarrays. Okay, so from that, let's go there. And then with this, just do a pass. So for element in strings, and then you can just do out. Okay. Oh, actually, probably just do a for loop here. So for IDX in range lang strings, for JDX in range IDX +1 lang strings, then just do the subarray here. Okay. And then with this, output equals this, so you're gonna append that there. Okay, so with this double nesting, I gotta be careful of, I have to be careful of introducing unnecessary time complexity. So I might, depending on this anagram helper, I might be getting n squared or quadratic or cubic time. I think it might be closer to cubic time, depending on if I use n elements checker or function right here. So, and then the space is just going to be the output, which is going to be on space. Okay, so from there, I have this like little subarray, and then I check the 2 elements. So if I were to do just a simple sort function, I think that would be on log n time times, so let's just do that, n times n log n. And then this is greater, but it's not the same level, it's going deeper. I'll have to go back to that. Let's see. Alright, so from there, now you check, oh, well, let's just do a simple check then. So output. Then at the end of this, if lang subr, which it should, yeah, actually I don't need that. Sub r, oh no, output dot append sub r. Okay, so should I have some sort of like tracker like this word has been used? Yeah, I guess I should. Let's just do that. String used equals false times length of strings minus 1, wrap that into parentheses. Okay. String used equals idx equals true. And then for this, if strings idx equals sorted strings jdx dot sort dot sort. So these are strings. In place. Okay. So I want new ones that don't affect the underlying string. Sorted. So actually, let me just make this easy. That helper is anagram helper. First string, second string. So if that's the case, yes. So now I'm going to have a function that basically returns true or false if they're equal or not. So if the length of first string does not equal length of second string, then return false immediately. Okay. So then I can just do a hash map here, I think, which might lead to so instead of doing hash map, I can just do a simple membership function. So for char in first string, if char not in second string, return false, else return true. And then in here, what you do is, okay, strings idx, strings jdx. Okay, so if here now I say string used jdx equals true, and then you append sub r dot append strings jdx. Okay, so with this, how can I use this true symbol? Okay. And, or so first, string used jdx. Actually, I would do it right there, I think, yeah. So if strings idx, strings str used idx, then you just continue to the next one. Okay. All right, and then yeah, this would get reset, until, yeah, then I just go forward. Looks good. Yeah, I think that looks good. Let's try to run it. Oh, I forgot to use self. Damn it. Okay. Self.is anagrams. Okay, let's run that. List outer range if so IDX in range line 1. So let's do that. Okay. So I forgot bats. Okay, so why is this out of range then? Because it's non-inclusive. Oh, is it because of this? Okay. It's because of this. I made it too small. Okay, cool. Yeah, so this is obviously not the best time complexity. So let's just like go through this and see which one I ended up actually using, because I think it's going to be closer to cubic time based on like how many for loops I used. So for this, what I did is I created essentially like a visited or used 1D array to check if it's been visited. So this for loop would skip it after it's done. For this output, I just append the results of the subarray construction. If it's been visited, then just continue to the next IDX element. Subarray, you put the element you're checking, and then in this sub for loop, this is an ON operation, this is an ON operation. Within here, you are doing an ON operation within this ON operation. So, well, let's see. Yeah, I'm gonna see it's cubic time. This is definitely not good. But it is ON space, so I didn't use a hash map within this. Let's see, pen there. Yep. So not perfect solution. How I'd probably optimize it is you probably use some clever indexing and a while loop to get the same result. But just for the sake of time, let's go to the next question. So, all right, let's reset this timer. Then go to letter combinations. So letter combinations, given a string, oh, this is the code number 17, by the way, given a string containing digits from 2 to 9, inclusive, return all possible letters combinations that number could represent. Mapping, a mapping of digit to letters is given below. Note that one does not map to any letters. Okay, so right here we have 2, 3, and then you have 2, 3, 4. So this is basically a permutations question or a combinations question, because let's see, yeah, 2 times 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2 times 3 times 3. So 3 times 3, yeah, that's 9, and then let's just say you have another one, that would be 9 times 3, which would be 27 options, and then, so this is going to be 3 factorial, I think, or like, sorry, to the third power, so, okay, so with that, I should probably have a hash map for the numbers themselves. So what we can do there is 2 to 9, phone letter combo equals this, ABC. Or should I do this in an array? Let's see, mapping the digits that is given below. It might be more useful to do an array then. Okay, well, let's just do this right now. 3 DEF, DEF. 4 GHI, 5. This might not be the best way to do it either. Maybe it just makes sense to have a whole big string with the whole alphabet, and then divide the first parts. Let's just say 22 divided by 8. Let's make sure. Yeah, so 26 minus 4 for that last 9 number. That should give you 22. Oh, and then I see there's an extra 7 which has another character. So in that case, we actually have 23. Oh, that's not missing anything. So we have 26 total characters between 2 and 9. So 1, 2, 3, 4, 5, 6, 7. 7 divided by 22. So that would be 3 for each one, plus 1 for 7. So yeah, I think you could do indexes there. KKL 5, 6, MNO 7, and then this is the 4-letter one, QRS, PQRS. Then you have 8, and then you have TUV, and then finally you have 9 at WXYZ. Okay, so with this phone letter combo, you have a string, a mapping of digits. Let's see, how big can the string be? But although the above answers, you can answer any way you want it. Okay. So yeah, this is going to be factorial, I believe, because you're just combining all these letters. Yeah, so like if you have AD and then you have a third letter, you're going to have that letter's amount of letters times that. So let's say you had 237, then it would be 9 times 4. So you would have 36 options there, I believe. Okay. I want to know how big the string can get. So yeah, digits. How big can digits get? So we have outputs that we want. Oops. So the first one we have A, B, C, right? Then that takes. Okay. I think I got it. So for digit and digits. Phone letter combo digits. So iterate over this string equals phone letter combo digit for char and string to iterate. Okay. To iterate output dot append. Char. Okay. Well, let's look at this. Else, so basically, when you first have it, just append those one letter characters. Then after this, like, you try to iterate through the output. So for elem in output, this is now where you want to combine the strings. Okay, so from this, how can I multiply these strings? So can I use a stack instead? So pop this. So use pop C. Maybe a stack is more likely. Wow, this problem is a lot harder than I thought. Okay, how to go from here? So maybe it's a string you have to do. So like last string. How do I iterate over these? How do I multiply them? Crazy. Okay. Mapping is given below. One does not map to any characters. So if you have 3, 4 numbers, then you're looking for combinations of that length. Okay. So if I have ABC on this first one, right? So ABC. Then second one I have, let's just say, yeah, DEF. I would get permutations based on that. So multiply. A D E A F B D B E B F C D C E C F. Okay. Yeah, so it almost seems like a stack would be best here. Okay, let's try it out. Stack. And Thunder Kamu. Okay, with this ABC. Then I'm trying to pop that, then do ×3. So maybe a Q is better here. Yeah, Q. Because you know, pop left. Amount to pop, because you're just gonna multiply every single time. Bitter. Else, and then this is where while amount to pop. Greater than 0. Cur equals cur letter Q dot pop, and then the front of the line comes my front line. And for the front line you do combo equals cur letter plus okay. Yeah. And then with this, what you're gonna do is I'm basically gonna, so 3 times 3. Yeah, okay. I'm gonna try to finish this out though. So basically what I'm trying to do here is with this, find the length of the string 3 and then the amount to pop. So 3 times 3 is gonna be 9. Then after that, at the end, you're going to pop those amounts the next time. And then let's say you do like 9 times 4 with like you choose 7. You have 36 combinations. And then like when you're done with all these digits, then you return the Q. So with this, let me just make sure this is right. Times amount to pop. Let me just make sure this is right. Let's just have these be out of here. Yeah, that looks good to me. Okay. Plus char, and then you just q.append combo. Then you just subtract the amount to pop minus 1. Oh, actually, after you do that all right there, then from there. Okay, so elif digit inf and then ling is greater than q. Then you create this new string to iter, and then from there you have your new total, which will be the length of this this string times the original amount to pop. While this amount to pop is greater than 0, then you pop the current element, then you iterate for that string to iter. You create those new combos, append those new combos to the end, and you minus amount to pop. After that's done, you will exit out of this, and then just loop over again for the digits. So let's check that out. Yeah, it's gonna take a long time. Oh wow, okay, cool. So this might not time limit exceeded. Okay, so I just gotta make sure for digits. Let's make sure what's wrong here. There's gonna be a lot of failed tests. Yeah, okay, so it's exiting quickly. So let's see what's going on here. So if this digit is in phone letter combo, which will be, I think we've tracked everything here. Make sure, yep. So do amount to pop. Oh, and then at the end, I'm sorry, at the end, you're going to want to do new total. Amount to pop equals new total. Forgot to add that one. Okay. All right, yeah, so this was successful, but so I used a queue. So basically, I have my strings out like this. So like A, B, C, and I just popped them like for the next one. So let's see, I had 3 next one. So I popped this, kept track of the amount to pop. So for this first iteration, I know I have 3, and then I check out the second digit, which is right here. That has 3 too, so I know on the next iteration I have to pop 9 elements, and that creates 36, and then so forth. So yeah, this is actually a lot of looping. Let's see what time this is. You'll go through here, so you loop for the digits, and then in the digits you loop for that. So yeah, this is definitely from a time space ON squared, because you go through every like iteration like forward. Actually, it might even be worse than that. It might be like actually 2 and time. It's a permutation. It's pretty bad. It's either that or this. I gotta look further into that. But I know the space is gonna be O of n because we're just creating this queue as we're going through that. Oh, but it is a lot of permutations, so that might be its own thing. I gotta look into this, so I'll get back to you guys. But you can see I can improve the time and space there. So let's go to the next one. Let's make sure the time is correct. Okay. Now we have this one. Oops. Let's reset it. All right, merge intervals. With this, I think this is just going to be a matter of you have the first element and then you just keep on seeing if the next two elements are within that range and how you can update that last element. Okay. So yeah, this overlapping thing. So what you can do is output equals intervals 0, and then I can just iterate through that. So for IDX UM in, actually for IDX in range 1 lang intervals So from that, now you check to see if those numbers are within. So let's see. So new num equals intervals IDX. So with that, now you check to see if this last number, oops. Yeah, this last number is within this. So you're always checking the last element here. And if it's not part of it, then you just move on to the next one. Okay. If new num 0 output -1, so the last one, and then from here 0. So if that's greater than or equal to new num 0, which is less than or equal to this 1 right here, so 1, oops. Okay, so if that's within each other, then you can check if new num if new num 1 is greater than this one right here, then that equals new num 0. And then you have to do the opposite. So if like one number is less than the first number, so you can basically just copy this, and you're basically just saying if that second number is in between these two numbers, and new num 0 is less than this first output 0, then this 0 equals new num 1. Okay. And And then if that's not the case, then else you just add that number to the end. I mean, you add that new num to the output. Else output.append new num. Let's check that out. Alright, so we have 1, 3, 8, 10, 15, 18. Okay, so that 6 should have wrote over this 3 right here. So output -1. So if new num 0, so this one right here, if that's greater than or equal to 1, so if 2 is greater than or equal to 1 and less than or equal to 3, then what you want to and new num 0, new num 1, new num 1 is greater than this. Okay. So the same thing here. So if this second number is in between these numbers and this first number is, let's say it's like -1, you have the 1 right here. Okay. Then this one should equal that. Okay, let's try that out. Okay, let's see if we have any edge cases. We probably will. Alright, so index outer range. Okay, so if intervals is empty, not length intervals, then you should return an empty interval. Actually, if we do less or equal to 1, then just return that intervals. Alright, let's try that out. Okay. Oh, so both of them. Okay, that's interesting. So in that case, both of them. So I could just do both of them. Okay. So this says like in between. If num is less than this and num 1 is greater than so this, I can just do both because if like, it doesn't really matter if you just reset them. Oh, I forgot to put a colon. Gotta be careful of those little one-off errors. Okay, let's see, 247, 67, 110, expected 110. Oh yeah, so you should just be able to iterate through that. Yep, okay, yeah, that makes sense. Okay, so now I just iterate through those. So then you reset that one, then let's reset the others. It's a tricky one. Let's look at the time. Oh, I forgot to set the time. Okay. Well, I gotta look into this one, but yeah, you can kind of see like the indexing. You're just like seeing if they were within the bounds. I know like a really good question for this is like obviously the merge intervals. There's a question on interview cake 2 where you're like doing meeting schedules there too. So basically you're just using this indexing to make sure they're within a certain range and then like rewriting them. So for this, I would have to just the greatest range, just like go through the rest of the array and make sure that whatever's within this greatest range, like just eliminate that from the output and then keep whatever's outside this range. So I'll have to go back to that, but thank you for joining. I hope you enjoyed this video, and I'm going to try to be a little bit more communicative the next round. So sorry for being a little bit quiet at this one. I should kind of communicate my ideas, my thinking for this, but yeah, it just comes with practice. So thank you guys, and see you next video.